to solve this integral here, what we're going to do is use integration by substitution to illustrate how this technique works and give you a practical example of using it. So integration by substitution is sort of the opposite of the chain rule for differentiation, and we'll see that as we run through this example. So if you've never seen this before, this technique might seem a bit weird, but we essentially just take a guess at a substitution and then work from there. So I'm going to take u, so I'm going to define a new variable called u. I'm going to set that equal to x squared plus 3x minus 5. Now the idea is, instead of having this integral, which is right now a function of x, and we're integrating with respect to dx, we want this to be a function of u and integrating with du, with the idea being that that integral will be equivalent but easier to solve. So if we're going to do that, we've got a value for u, but we're going to need to find what du is. So the way we do that is by differentiating u with respect to x, which gives us 2x plus 3, and then we can rearrange this to give us dx is equal to du over 2x plus 3, with the idea being that now we can substitute that expression in to here. So we're going to go ahead and do that. So now we have the integral, we still have our 20x plus 30, but we're going to factor out 10 here. So 10, 2x plus 3. Now this x squared plus 3x minus 5 is our u. So here we just have u to the power of 9, and instead of dx, we have du over 2x plus 3. So now we've got 2x plus 3 here, and we've got a 2x plus 3 on the bottom here. So these cancel each other out. So now we have 10. We can bring that outside. The way integration works, you can bring a constant out. So anything that's not explicitly dependent on u can come out. And then we have u to the 9 du. Now this is a standard integral. We raise the power up by 1 and then divide. So this gives us 10 u to the 10 divided by 10. Oh, got a bit close to the bottom of the screen there. Plus c. Of course, these 10s cancel each other out, and we end up with u to the 10 plus c. But of course, we want to write our integral back in terms of x. So this is equal to, and all we do is substitute u back in here. So now we get x squared plus 3x minus 5 and plus c. So hopefully you can see the idea here.